Well, I do every time.
Okay, well then you should be fine, right? Nothing to worry about. What up? So,
Can I just use the bathroom? I'm
yeah.
gonna take her.
Maybe we'll warm up today.
Sorry. I'm now in the bathroom.
Guys, warm up sheets. Here it is. Find the pattern. Represent the pattern with an equation. That way you can figure out what step 45 would be. So, for instance, step 1 would be n equals 1. We don't use s for step because we avoid s's at all costs because they look like 5s. N equals 2 is the second step. N equals 3 is the third step, and so on and so forth. No, we're not. I printed off a bunch. There's no way.
Where are they? So these are the brass?
Does anybody know anybody in first hour? Hate them. Hate all of them. Why do they take this? They do this all the time. I don't print off more right now, but just use graph paper. It'll be fine.
Wait, graph paper?
Yeah, use graph paper. All right, so when n equals 1, how many squares are there? 5. 5.
Cinco.
When n equals 2, how many squares are there? 9. So on and so forth. If you can't figure out the equation, that's fine. You can try to figure out what it means. Talk to me about how you see this problem. There are multiple ways to see it.
Wait, like how we can add it up with the last one I could do like equals 305.
Where is it?
Is that how you
Well, what's that?
I guess it works.
Sit down. Go sit down. Sit down. All right.
Mr. Med, gotta catch him.
That's how you
All right. So song of the day, background band, colder weather. I figured it's appropriate. The album you got to give.
Cause we
Get it going.
Oh, we gotta get a new.
She'd take Colorado if he'd take her with him. Closes the door before the winter lets the cold in, and wonders if her love is strong enough to make him stay. She's answered by the taillights shining through the window pane. He said, I wanna see you again, but I'm stuck in colder weather. Maybe tomorrow will be better. Can I call you then? She said, you're a rambling man. You ain't ever gonna change. You got a gypsy soul to blame, and you were born for leaving. At a truck stop diner just outside of Lincoln. The night is black, the coffee he was drinking, and in the waitress' eyes he sees the same old light is shining. The banks of Colorado and the girl he left behind him. He said, I wanna see you again, but I'm stuck in colder weather. Maybe tomorrow will be better. Can I call you then? She said, you're a rambling man. You ain't ever gonna change. You got a gypsy soul to blame, and you were born for leaving. Born for leaving. Well, it's a winding road when you're in the lost and found. You're a lover, I'm a runner, and we go round and round. And I love you, but I leave you. I don't want you, but I need you. You know it's you that calls me back here, baby. Stuck in colder weather. Maybe tomorrow will be better. Can I call you there? 'Cause I'm a rambling man. I ain't never gonna change. Got a gypsy song to play, and I was born for leaving. Born for leaving. When I close my eyes, I see you. No matter where I am, I can smell your perfume through these whispering pines. I'm with your ghost again. It's a shame about the weather, but I know soon we'll be together. And I can't wait till then. I can't wait till then.
Okay.
Got a gypsy soul.
Nope, we're not doing that.
You got it stuck in my head.
Okay. All right, so writing the equation, depending on how you look at it, can be kind of crazy. But seeing the pattern, what's going on, I don't think is too bad. So tell me how you see it. Both ways to do it. Yeah.
You add one to every corner.
Well, add one to every corner. How many corners are there?
Very good, Coda.
4, right? So we take the last thing and we add on 1 for each corner. So no way to see it. Yeah.
I did 4.5n plus 1 minus 0.5.
Let me write that down so we can see it. 4.5n. And what?
Plus 1 minus 0.5n.
Okay, so you're saying we can combine this stuff, right? And just get 4n? Why did you write it like this? You're right, it could be simplified, but like the way he wrote it out is telling the story of how he saw it. So where did you get 4.5 from? Zane, you want to tell him?
Oh, the
I
middle.
divided 9 by 2
9 by 2. Why are we dividing 9 by 2?
because that's the step that 9 gets. That's the step of which you get 9.
Okay, so this number right here, you divide it in half. And you got 4.5. Why'd you do that though?
Because then I noticed that if you were to take 4.5 times 1, you would get
4.5.
4.5, but then you would have 0.5 to go to get to 5, so you would take 0.5 from 1 and you would get 5.
Okay, let's see if this works. So step 3, how many squares are we supposed to have? 13. And using our pattern of adding 4 each time, we know step 4 is going to have how many? 17, right? So on and so forth. So if we plug in 3 for n, we get 4.5 times 3, that's going to be 13.5. 13.5 minus a half 3 times. So 13.5, subtract a half 3 times. 13.5 minus a half once is 13, minus a half 2 more puts us down to 12. 4 plus 1 is 13. And again, there's a simpler way to think of this. You can just write 4n plus 1, right? These combine, right? If I go to n equals 4, we get 16 plus 1, which is 17. If I have n equals 5, we would expect to get 21, right? Well, that gets us 21. So this is the simplest form. Why? You just happen to notice that if you cut it in half and do this, it works? Okay, cool, fair enough. Let's think about what that means geometrically. 4.5 cut in, 4.5 plus 1 minus 5, 0.5n.
Interesting.
1, maybe the center square. Maybe that's what this one stands for.
Yes.
And we're adding on 4n. So 4 for each step. So there's 4 around that for step 1. There's 4 plus 4 more for step 2. And there's 4 plus 4 plus 4 for step 3. 3 groups of 4 added on there. So what he's doing is he's thinking about, again, I'm not sure how to explain that necessarily, but I can explain this, right? Start with 1 and add x's around until you reach the number of steps, right? Step 3 has 3 circles of x's. Do you see what I'm saying here? Like, it has rings of these 4 squares. That's his way of looking at it. So 4n plus 1. Is there another way to look at this? Any art students here? Anybody in art class?
Of course not.
No, gotcha. So you don't see it probably this whole first hour did.
I thought you hate everybody's first hour. Because I heard that.
You what?
I heard that. You said you hate everybody's first hour.
I hate everybody, everything, everywhere, all the time.
Honestly.
Everybody can the whole concept of anger and hate. Duh.
It's huge.
It's not what it's saying, okay. How about this? What about the negative space?
It's a shame about the
This is a 3 by 3 square, right? But we subtract 4. This is a 5 by 5 square, but we subtract 12. I'm sorry, not 12, 16. This is a 7 by 7 square, but we subtract 1, 2, 3, 4, 5, 6, 7, 8, 9 times 4, which is 36.
So it's a big box.
So another way to think of it is make the box first and then subtract away the stuff until you're left with what you want, right?
Quarters.
So we have a 5 by 5 when n equals 1. We got a 5 by 5, and then we're going to subtract 4, right? And we have n equals 2. We've got a, I'm sorry, not a 5 by 5, that was a 3 by 3. We got a 5 by 5, and we subtract 1, 2, 3, 4. So the total number we did last time, but just 4 times that, 16. We have 7 by 7. We're going to subtract 30, was it 36? What do we have here? 4, 5 down here, 9 times 4, yeah, okay, 36. Another way to think of it, how would we write that algebraically? That's a tough question.
Ooh.
When n is 1, we have a 3 by 3. When n is 2, we have a 5 by 5. When n is 3, we have a 7 by 7. How would we write that? Ignore all this. When n is 1, we have a 3 by 3. When n is 2, we have a 5 by 5. When n is 3, we have a 7 by 7. Yeah.
Each time you're adding 2 to the number of that you're.
I guess this is 3, right? For a 3 by 3. That gets us 4 for a 4 by 4. So that doesn't work. Yeah.
It's the previous equation.
This is the word I'm looking for. Okay. Pause on this. Okay, you might not have a chance to come back to it with pause. Looking at the previous step. A lot of you guys said that, hey, look, we just add on 4 squares from the last guy, right? We look at the last picture, we add on 4 squares, and we get the next picture. So what we do is we look back to figure out what the future will be. Which I think is metaphor for life, right? We don't live in the past, but we do reference it as who we are. It can help us figure out the rest of the future. So what we call this is recursion. It's looking back on the last step to figure out the next step. And here's how we write it. So there's this, we call this an explicit, right, equation, because you can plug in the number and you get an answer. It gives you the direct thing, there's no looking back, it's just here's what it is, right? That's nice. There's another way to look at it called recursion. Here's what it looks like. So first off, you remember this maybe a little bit from algebra, f of n equals something, right, means it's a function. The idea is it's some kind of machine. You put something in, something pops out. Only one thing pops out, and it's always the same thing every time. That's what makes a function, okay? Think of it like a vending machine. You go there, you put money in, you hit the button, the thing that you want pops out. And it tells you what's gonna pop out. What's gonna pop out? Well, it depends on what's over here, right? If I have n plus 1, it says if you plug in 1, out pops 2, right? That's the idea. When you plug in 1, do you ever get 2 and a different number that pops out? No, it's always gonna be one number, 2 pops out when you plug in 1. A function is an equation that pops out one thing for one input. So 1 to 1. So you put one thing in, you get one thing out. You never put one thing in, you get two things. It's not a really broken vending machine, which is unfortunate, right? We wish things worked like that. If one doesn't, two things drop. Good day, good day. That's all functions are. So, this function, you said we're gonna look at the last guy and add 4, right? So how do we write that mathematically? We look at the last guy and add 4. Well, the add 4 part's pretty easy. How do we get to look at the last guy part? Well, this guy right here says the output for this is the output for the number that we're on. So if we're on step 2, f of 2 is going to be 9. The output is 9, right? F of 1, what's f of 1 for this? 5. What's f of 3? 13. You see how that works, right? This says the output, the function of 2, right? When you plug in 2 to the machine, out pops 9. So this represents the current output, right? If you want to figure out what's happening in step 45, you plug in f of 45, and it will tell you what it is. But what if we want to look at the step before that? We wouldn't want f of n, because n is the step we're on. If we're on step n, what's the step before n? If we're on step 3, what's the step before 3?
2.
How did you do that? -1. So what we want is the output, the last picture, okay, of the step previous. And that's what this means, f of n minus 1. Looks like a bunch of math mumbo jumbo, but what it means is, hey, I want the output, because that's what f is, right, of the step before. The step we're on, minus 1. So take the guy before and add 4. Does this work? F of 3. We know the answer, it's 13, right? So if we plug in f of 3, that means we have this, right? And what are we plugging in for n? 3. So there's a 3 there as well. What's 3 minus 1? 2. So f of 3 is going to be equal to f of 2 plus 4. F of 2 is the previous step. What is f of 2? 9. The previous step. You see how that works? So f of 3 is going to equal f of 2 plus 4. What would f of 4 equal? F of 3 plus 4. What would f of 5 equal? What would be f of 4 plus 4, right? It says look at the previous guy and add 4. That's what this means. Look at the previous guy and add 4. We call this recursion. It looks back on itself. Computers are super fast at making these calculations, and so it's not annoying for them to have to go back before they go forward, right? And so recursion is used an awful lot in computer science. Sometimes things aren't as simple as what you guys wrote, right? Start with the first square, add 4 each time, right? Sometimes things are more complicated when we need recursion. So 2 ways to look at it. Look at the last guy and add 4, which is how most of you guys, I think, actually saw it. You saw this. You just know how to write it. Others of you saw start with 1 square, add 4 for the number of steps you're on, right? Step 1, add 1 group of 4. Step 2, add 2 groups of 4. Step 3, add 3 groups of 4. Okay? The key takeaway from this is what does this mean? F of n minus 1, bunch of math mumbo jumbo. What does it mean? The previous step, right? F of n is the current step's output. This is the previous step's output. Someone explain to me what this means. Go ahead, Ryan. step 3, you could look at step 1, and how many squares would you add to get to step 3? From here to here, we added 4, right? You added 4 from the last step. How many squares do I need to add to get to here, to jump from here to here? 8. So another way to represent this would be this. The step you're on, f of n, is going to equal f of n minus 2, the previous step, the previous step, plus 8. What do you think about it? The problem with recursion, there's no step before this, is there? So if I said, okay, what's f of 1? You'd have to say, look at the previous step. Oh wait, is there a previous step? There isn't. So either you'd have to say, look, f of 1 is 5, we're just starting there, just trust me, okay? It's 5, don't think about it. And then you can start moving forward, right, with the last guy, add 4, we get 9, right? Or you say f of 0, the step that's missing, is 1. Imagine if we went backwards, right? We're adding 4 squares each time. If we're here and we work backwards, what would it look like? Just 1 square, right? That's another way to think of it. But again, at some point you have to say, that step is a number, because you have to have a starting point. You can't just keep looking backwards, right? If I had a 1 square here, what would the step before it look like? -3, right? At some point you have to tell them where you're starting. That's the problem with recursion. What's nice about this explicit formula, you don't have to tell them where you're starting. You don't know step 1, plug it in. You don't know step -5, plug that in. Negative squares, right? Put that away. I bet this is right out. No? Alright, Danny, this is...
Need more jokes.
Any more jokes?
Yeah, you need a funny.
Yeah, I know.
I'm starting to doze off.
Oh no!
More, keep it interesting.
That's going to be
No, I just know that's Dos Equis
Yeah, it was better when they had the most interesting man in the world.
Yeah, now it's just the one dude.
The one dude that looks like Michael Phelps.
Yeah. He's not the most interesting.
No, he's not.
He's far from.
Yes.
All the way.
Yep. That's what we got. That's what's for dinner. All right. Popcorn? We've done this already. Do you have it still? Wonderful. Any questions on the first set of questions before we get to the perpendicular stuff? Before we get to here, were there any questions? Before we get to here? Nah? Okay. Then flip to this page where it has the directions for the perpendicular section, the dots and lines. It says, find the slope and equation of the given line, and then find perpendicular slope to the given line. Then find the equation of the perpendicular line that goes through the given point. Graph that line. Okay? So. Cocaine, guys. Not even once. Not even once. All right. That's advice. Don't do it. I'm being sincere. Do not do it. There are drugs and then there are drugs. Do not do that. All right. Find the slope and equation of the given line. So here's the given line. First of all, let's find the slope. M is for slope because duh. Slope starts with M. Parlez-vous français. All right, so the slope. How are we going to figure that out from the picture, graphically? How are we going to figure that out? Pick 2 points, right? Normally when we do it algebraically, we take 2 points, plug into the slope formula, right? Subtract the rise over the run, subtract the run, etc., blah, 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 but, you know, words are hard. So here's a nice point, and here's another nice point. Again, pick ones that are nice and easy to see. You don't want fractions, right? And these points right here, I can either do algebraically to find the slope, right? Use slope formula. This point is 0, comma, looks like 5, 1, 2, 3, 4, 5, yep. And this point right here is 1, 2, 3, 4, 5 to the left, and 0 up. So I could use my slope formula, rise over run, to figure that out. And remember, slope formula is just the y's being subtracted, right? How much we've gone up. Y's are how much we've gone up. Subtraction is distance, right? So I'd subtract my y values. 5 minus 0 is 5. Then I'd subtract my x values, put it on the bottom. 0 minus negative 5 is positive 5, so we get 5 over 5. Right? That would be my slope. Or we can do it visually. So if you haven't been following up to this point, now's the time for you to show up, okay? So check it out. How far are these points apart? Well, horizontally speaking, starting at the bottom, just like Drake, except he didn't, we're going to move 5 to the right. Drake was born in Canada to rich parents and had free health care his entire life. He did not start at the bottom. But again, that should be the bottom for everybody. Debatable. And then we also go up 5. Now, what if you had started here? I started down here. What if you had started here? You would have gone down 5 and then left 5. You would have got double negatives, right? Same dumb slope, as we'll see in a second. So this is a slope of 5 over 5, which we know it can be simplified, right? We can simplify that to what? 1 over 1. I don't think that's true, but that's okay. We also know this is the same thing as this, because we could also have gone down 1, left 1. Again, it's your perspective. I went right and then up. You could have gone from this dot down and then left. They're the same dumb crap. Do we agree? Another way to look at it. Now, what does this mean? What does this mean for our equation? Our equation is going to be y equals, we're writing in slope-intercept form. We call it slope-intercept because that is the slope and the intercept. First is our slope, which we said was 1 over 1, which I'm just going to write as 1. You could have also just written x. What's the y-intercept? What's our y-intercept for this equation? Katie? 5. We cross the y-axis at 5. Everybody see that? Where we cross the y-axis is our y-intercept. The idea is that we have a regular line that always goes through the origin, right? It just changes the angle. That's all that slope does. And then the plus 5 raises that line up. Okay? Kind of like we were doing with Desmos. If we didn't have the plus 5 there, this guy would go through the origin. And that number right there only changes the angle, right? It's the slope. So when we add that number on the side, it just takes that line and shifts it up 5. So it hits the y-axis at 5. So there's the given line. Now it says we're going to find the perpendicular slope to the given line. Okay? So here's slope. Let's find perpendicular slope. So I'm going to use m with a little perpendicular subscript. Because like it's rad to write math like that. It just makes you look smart. Perpendicular slope. Now, what do we do to find perpendicular slope? We take the given slope and do what? What do we do to it?
Flip and negate.
Flip and negate, that's right. Flip means to flip the top and the bottom. If I have got 1 over 1, it's not going to look any different, but we flipped it, okay? We flipped it. You just can't tell. Now, what does it mean to negate?
Negotiate.
No. What did you say? Make negative. Now, technically you're right, but if I say that, you're going to get confused, because what if it's already negative? Are we going to make it negative? We're going to make it positive, right? To negate it means to change the sign. Why? Because we're multiplying by -1, right? So it was positive, so now we make it negative. Does it matter whether we put the sign on the top, bottom, or the side? No, it's all the same. I'm going to put it on the side here. There's our slope, which means our equation. Erica, what color is our line going to be for our perpendicular? Blue.
Drake really didn't start us off with that.
Which one?
The light one.
Okay. This is the wrong choice, but it's fine. All right, so our new equation for our perpendicular. So if that was our original line, here's line perpendicular. Our equation is going to be y equals our negative slope, so -1x. You could also just write -x, right? And we're going to figure out our y-intercept in a second, because again, we don't want a line that's perpendicular to this, just perpendicular, because there are infinitely many lines that are perpendicular, right? I could draw a line like that, like that, like that, like that. All of those would be perpendicular. We want a line that's perpendicular and goes through this point. That's only one line. So we need to find that particular equation. So the way we're going to do it is we're going to use our slope. Remember, our slope is down 1 to the right 1. So if I go from this dot that I know is supposed to be on that line, down 1 to the right 1, and I keep doing that, Well, then I'm going to get my line, right? That goes through that point and hits it at 90 degrees. Now, as you can see, the dots I'm making don't hit the y-axis. So we still don't know our y-intercept. But remember, a slope of -1 over 1 is the same thing as 1 over -1. So here I did -1 down 1 over 1, right? I did this slope. I did this one right here. But I could also think of slope like this, right? Up 1 to the left 1. That's what this means. Up 1, that's our rise, and our run is to the left. And if I do that, I'll get points that actually cross the y-axis, and we'll see where it hits our line. There it is. So now you can see if I go up and to the left, right, just the opposite of what I had done down here. It's the same thing, just a different way of looking at it. I now know my y-intercept. What's the y-intercept going to be? +1. So there's our equation. -1x plus 1, or just -x plus 1. I'm going to zoom out just a little. Sorry, Autumn. I'm going to draw my line. So, Autumn, I have a bunch of students that have trouble seeing, and 2 of them have already gotten glasses recently, and they look amazing in the glasses. They're really nice. Lainey got new glasses, Chloe got new glasses, and I'm working on getting Macy glasses as well. You could be next. Because they can't see. Shut up. So this hits it at 90 degrees because it's perpendicular, and we know that for sure because we use perpendicular slope, right? And it goes through the point that we wanted. So here's the equation of that line. Questions on that? How did we feel about finding the slope of the line that was given to us? Pretty good? All right. How do we feel about writing the equation of the given line? Finding the y-intercept, we're okay? You mean you guess? Katie. Here's what we're going to do. Thank you for saying that. Were you cool with us getting 5 over 5? Okay. We cool seeing that changes to a 1, 5 divided by 5? Okay, so we're fine up to there. Do you see where we got that 5 from? It's kind of a coincidence. You might think like, oh, it's here or here if you weren't paying attention, like, and you just checked in, right? But we got it from this. Everybody. Y-intercept is at 5. Coincidence. They're all 5s. How do we feel about getting perpendicular slope? Flip and negate. Change the sign, right? How do we feel about finding the y-intercept here? Using our slope from the given point. Feeling better? Okay, good. Again, none of that I don't think was rocket science, and I think you would agree, right? It's not hard to understand those individual concepts. It's that when it's all at once, it's sometimes hard to keep up, and you might not see it at first. So ask the question that has an answer this small that's going to unlock the rest of the world for you, right? Because if you didn't ask, then you're stuck on something. And it's silly because you're stuck on something super easy, right? But it's only super easy if you see it. If you don't see it, it's impossible. So help me help you see it. Don't be afraid to ask. It's super important. It took me till senior year of college to figure that out. Seriously.
Which one?
Exactly. The first time. This guy. So the line they gave us, first of all, here's a problem that stumps calc students a lot. How do I write the equation of something like this? And it's not because calc students aren't smart, right? Calc students are. They're in calc, right? They got to be smart. It's because they don't know what it means. They think y equals mx plus b, and that's all they know. And they know the formula. They plug stuff in. Slope is m. But they don't know what it means. Look at this. Slope is what over what? Rise over run. So it's how much we're going up and how much we're going over. So if I pick a point on this line right here, to get to another point, I go up some amount, right? Looks like from here to here I go up 4. How much did I go over? 0. So our slope is 4 over 0. 4 divided by 0. What happens when we divide by 0? Breaks math, so it is undefined. This slope is undefined. So we can't plug in a number for m. We can't have a y equals mx plus b. It doesn't work. It breaks math. You can't plug in 0 for m. 0 is not the same thing as breaks math. 0 is a number. We're fine with 0. There's no way to write the slope-intercept form of this equation. So we have to think about, what does this mean? This line contains all of the points that have something in common. What do all of these points that I randomly chose have in common? I'm sorry, raise your hand because I got too many people talking. I love that we have that, though. x equals 7. This point right here looks like 7 to the right, and 1, 2, 3, 4, 5, 6 up. This point right here is still 7 to the right, but it's 2 up. This point right here is 7 to the right, but it's negative 3 down. This point right here is 7 to the right, but it's negative 5 down. This point right here is 7 to the right, and it's negative 7 down. You see they all have something in common? X is 7. So the way we write the equation of that line is we say x is 7. It's the line where everything is 7 for x. Does it tell us anything about y? No, because y could be anything. There's no relationship between y and x. We talked about this last week. The relationship here between y and x is y is whatever negative version of x is plus 1. Change the sign, add 1, right? There's a relationship between x and y. Here, there's no relationship between x and y. X is 7 all the time. Y can be whatever it wants. X is always 7. So that's the equation of that line. There is no y equals mx plus b version of this. X equals 7. Now, if we want a line that's perpendicular to that, perfectly vertical, right? This is going to be perfectly horizontal, isn't it? So we want a line that's perfectly horizontal and goes through this point. Well, that's super easy to draw. There it is. Now the question is, what is the equation of that line? First of all, what's the slope of this line? Yeah. You're right. What's the slope of this line? Think about it. How much do we go up between 2 points? Pick 2 points. How much do we go up? 0. How much do we go over? Well, in this case, I picked a point that's like 6 apart. So 0 over 6. What's that? 0. 0 divided by anything is 0. I've got 0 things, 6 friends. How much does everybody get? Everybody gets 0, right? You all get nothing. Nothing! You lose! Right? Willy Wonka, Gene Wilder, the original. So, no slope, so 0x. What's the y-intercept here? Where does it hit the y-axis? At negative 2. Now, there's an easier way to write that. What's 0 times anything? What's 0 times anything? 0. So that 0x is just nothing. Nothing! You lose! Right? Minus 2 is negative 2. Y equals negative 2. What does it mean? That's not miss. Y equals negative 2. What does it mean? What does it mean? Y is negative 2. Every point on this line is going to have y equals negative 2. That's what it means. You did something that calc students struggle with. What it means is the only question. I don't have to do all this crap if I just know, look, y is always negative 2, x is always 7. Done.
What does AP stand for?
Question. Where will these two lines intersect? Don't look. Don't look. Look. Eyes up here. We have a line where y... Don't do it! If y is always negative 2, if y is always negative 2, and x is always 7, where will they intersect? What coordinate will they intersect at? 7, negative 2. No, keep it going. Keep it going. Keep it going. This is for you. This is for you. No! No! No more! Too much. No! Okay, when I used to do music, I used to get like, you know, like when you teach music, you can either just like, okay, everybody stop, right? Or you can like do this. So let's practice that. Let's practice that. Everybody clap. And, no, you gotta watch me. Watch for the cutoff, okay? Let's do it again. Boo! Evan, you weren't watching, right? But it's magic when you cut off like that. It's just like, bam, everybody's done. We need to do that from now on, okay? That means just shut up. I miss that. Being able to, without words, just have everyone shut up. All right. You think you got a handle on that? Wonderful. Turn the page. No. No. I did. That's not how that works. And I dare you. Okay? On camera, assaulted by child, I can defend myself, right? All right. And boy, will I defend myself, right? Oh, man, I will take that opportunity. All right. Look at this one. Next page, look at this one. There's the line. I know it's kind of hard to see because it's going across the y-axis, but see the arrowheads there? There aren't arrowheads here. So that's the line we're talking about right here. Okay? what is the equation of that line? Pause, better question. What does this line represent? It's all of the points where what?
Y. 0.
Where x is 0. And you're thinking, wait, I thought y was 0 here. Here's how you can check. Pick 2 points randomly on this line. What do they both have in common? X is 0, this is some y value. X is 0, this is some y value. I don't want to count it, but it's 3, right? Okay? X is 0 for the black line. And that makes sense, because what kind of slope is this? Undefined, so there should be no way to write y equals mx plus b, because m just explodes everything, right? Now, we want a line that is perpendicular to that. So we have perfectly vertical, we're going to get perfectly horizontal. Draw that line. Somebody tell me the equation of the line that I'm about to draw.
X equals no.
What is it? Y equals 3, because every point on that line is where y equals 3. And notice they intersect at 0, 3, where x is 0 and y is 3. Fun fact. How you like them apples? Good. It can be. Vertical and horizontal lines can be so easy if you actually know what they mean. But if you don't, it's really hard, because it's like, oh crap, what's the y equals mx plus b, right? Oh, there is no slope, right? But if you know what it means, you're good. If you know what it means, you're good. Turn back to where we were. We're back here now. The bottom. Okay? Here we are. First of all, slope of the original equation. How are we going to figure that out? Somebody walk me through it. Xavier. Perfect. How are we going to figure out the slope of this line? Yeah, we're going to pick 2 points and go down and over, right? So here's a good point. And here looks like a nice point. Right? So starting at the top, you could start at the bottom if you wanted like Drake, but I'm going to start at the top.
He started at the top.
I go down 2, right? And then what am I doing, Xavier? I'm going over how many?
Well, until you hit the other line, I can't count how many
That's 5. It's 5. Now is it positive or negative?
We can't see.
I'm gonna have to say that's positive.
Why do you say it's positive?
Because you're going towards the positive.
We're going towards the right. We're going towards the positive, right? Well done. So our slope is rise over run. That means negative 2 goes on top. Don't screw that up. Rise goes on top. Run. Is that as simple as it gets? Yes. There is another way to think of it. What's the other way to think of this?
1.
No, it can't be simplified. What's another way to think of down 2 over 5? We started at the top. You could have started here. We could have gone up 2
2.5.
and then back 5, right? If we had done that, it would be like starting here, up 2, back 5. Just another way to think of it. Right? Both the same. I'm going to pick the one that does this. Y equals negative on the outside 2/5 x. Right? Kind of encapsulates both ideas. Fence sitting, if you will. What's the y-intercept for this guy? Oh no! Oh no! Oh no! It's weird!
It's in the
That's what Danny's parents said when he came out. Right?
Wait,
Of the womb.
where'd you find it?
Okay. Oh no, it's weird!
Oh,
Yep.
it's right here.
Sorry, Mrs. Mao.
Michelle.
There's nothing we can do.
Michelle.
Your mom's name's Michelle? I know mom's name's Michelle.
Oh,
Yeah. Yeah. All right, I know, right? So, imagine we're brothers.
I can see it.
I used to be a twin. I told you this, right? Can you imagine? I used to. There's a story there. All right, so it's only sort of sad. So here's the deal. So the y-intercept is this weird point here. Are we just going to guess? No. We're going to think. Another way to think about slope. Eyes here. Pay attention. You're not going to get this on your own. Let me lead you to the promised land, okay? Another way to think about slope. Don't think of it as 2 separate numbers, a rise over run. Think of it all together, negative 2/5, right? What that means is, if we go to the right 1, we go down 2/5. Now, we don't normally think of it that way because that's just gross, right? Going down 2/5. That's not useful. But here it will be. If I start at the top and I go to the right 1, I go down 2/5. Do you see where I am?
Yes.
Okay, well, what happens if I go to the right 1 and I go down 2/5? If I go to the right 2, I'm going to go down how many fifths? I'm going to say it again. I go to the right 1, I go down 2/5. If I go 2 to the right, I go down 4/5. If I go to the right 3, I go down 6/5. 6/5. If I go to the right 4, oh, now we're talking. I'm going to go down 8/5. So I'm at 4 for a height, and I went down 8/5. So where is that? It's going to be 4 minus 8/5, whatever that number is. Okay, 4 minus 8/5. Again, how did I do that? I started here. If I go to the right 1, I've gone down 2/5, because that's my slope. If I go to the right 2, I've gone down 4/5. Do you see the pattern? If I go to the right 3, I've gone down 6/5. If I go to the right 4, I've gone down 8/5. So I was at 4 and I went down 8/5 to get there. So where am I? We're going to do some subtraction. Ladies and gentlemen, how many fifths are in the number 4? Better question. How many fifths are in the number 1? 5/5. You dig? How many fifths are in the number 2? 10/5. How many fifths are in the number 3? 15/5. How many fifths are in the number 4? Jazz hands. 20/5. So we have 20/5 is another way to think of the number 4. It's the same number, just a different way of looking at it, right? Changing our perspective. We could all use more of that. If I have 20/5 and I take 8/5 away, how many fifths do I have left? 12/5. So my y-intercept is 12/5. There's the original equation. Zoom it out. It's gross, but that's what it is. Some lines aren't perfect. That's okay. Disgusting! All right, now we need a line that's perpendicular to that. So we need the slope that's perpendicular. What's our perpendicular slope going to be if our original slope was negative 2/5? Do it on your own. See you tomorrow. Yeah, they busted him.